Hello and welcome to our presentation on predicting an author's educational background using text mining. My name is Corten, I'm a sociologist at Utrecht University, and this is joint work with Shiva Nadi, who is a data engineer also at Utrecht University. The background of this project is in my own research on online interaction, in particular issues of trust in online interaction. Now, obviously, online interaction has increased immensely in the past decades, leading to a number of consequences related to text. So first, the volume of user-produced text has increased immensely, leading to a lot of text that can be used for research. More substantively, I would argue that the role of written text has increased a lot in social and economic interactions. So let's look at the example of the platform economy, which is one of the main things I study in online interactions. Think of platforms like Airbnb or eBay, etc. So on such platforms, there are huge trust issues. On Airbnb, you have to, for example, rent out your house or even a room in your house to a complete stranger. Now, one of the ways in which platforms address this trust issue is by trying to make the relation personal. And in this sense, they put a lot of emphasis on authenticity and self-presentation. So as both a host or a guest, you're expected to reveal a lot of personal information about yourself in order to make this a personal relationship. However, this also opens the door to all kinds of forms of discrimination and inequality. There's by now a lot of research that shows that people from certain ethnic or social backgrounds are less likely to get rooms on Airbnb or are less likely to get good prices for similar rooms on, for example, Airbnb. So if this is the case, that social background matters in such interactions, and if user-written text, such as the text written on this profile by this guy named Danny, if such text plays a role in self-presentation, then you could hypothesize that the way that people present themselves in written text has an impact on outcomes on such platforms. Now, of course, this argument makes a lot of important and strong assumptions. For example, it makes the assumption that people can actually assess someone's background from user-written text. So this project is meant to take a first step in this direction and exploring such questions, and also in exploring to what extent text mining can be relevant in addressing these types of substantive sociological questions. So the question that we address specifically in this project is to what extent is social background, in particular level of education, reflected in written text, and how can we actually measure this? How social background is reflected in written text, you need a dataset that contains both user-written text and detailed information about the social background, in particular level of education of these users. Now, unfortunately, most datasets about the platform economy do contain written text, but not a lot of information about social background. So instead, we use a dataset about online dating. The big advantage of that is that in online dating platforms, you typically provide a lot of written information about yourself, and in addition, a lot of more or less standardized information about social background. In particular, we use a data set from OkCupid, which is a US-based online dating platform. In particular, we use a data set that was released by OkCupid containing information of about 60,000 San Francisco-based users, containing all their profile information, including written text and information about social background. A level of education in this data set was measured using an open text field in which users described their own level of education. So this variable needed to be cleaned and recoded. We recoded it using the ISCED 2011 International Classification of Levels of Education, which provides this standardized scale of levels of education. So with that, I give the floor to my colleague Shiva, who will talk you through the further data processing, the methods of text mining, and the results. And I will get back to you for the discussion.
As we discussed in previous slides, we are working on OkCupid dataset. As you can see in this slide, the dataset is highly imbalanced, and we have very small number of instances in educational levels number 1, 3, and 5. by merging the education levels number 1, 3, and 5 as primary education and educational levels number 6, 7, and 8 as high education, we are facing a binary problem for our classification task. In order to make data ready to be fed into the machine learning algorithm, several pre-processing steps are taken, including encoding the level of education for each instance in the dataset to the international standard level of education, merging the ISCEDs for each instance to be considered as a unique text. Some data cleaning tasks, including removing HTML tags and removing numbers, extracting some stylistic features such as number of misspelled words, number of punctuations, number of unique words, average length of words, average words per sentence, number of characters, and number of words. Removing subwords from the text and turning all the characters to the lowercase format. To select a proper classifier for this dataset, we have tested 3 different classifiers on this data: naive Bayes, logistic regression, and LSTM. As we can see in this table, LSTM is performing best among these classifiers. However, logistic regression is doing fairly close to the LSTM. We are looking for a model that not only performs well, but also is interpretable. So we have chosen to continue with logistic regression. 4 different approaches are tested in this experiment. In the first approach, bag-of-words are the features that are used for building the classifier model. In the second approach, bag-of-words and linguistic features are used as input features. In the third approach, we use LIWC features for building the model, and in the last approach, both LIWC and bag-of-words are used as input features. LIWC is abbreviation of Linguistic Inquiry and Word Count. LIWC package counts words in more than 90 psychologically meaningful categories. LIWC relies on internal dictionaries that define which words should be counted in which target category. LIWC receives our dataset in the CSV format and goes through each row of dataset word by word. Each word would be compared with the dictionary file LIWC 2015, and the associated category would be distinguished after going through all the words in the text. LIWC would calculate the percentage of each LIWC category. For example, we might discover that 2.3% of all the words in a given text are impersonal pronouns and 3.3% are auxiliary verbs. This slide describes the steps that we have taken by this experiment from the raw data to predicting users' educational background. The original dataset contains text. Using LIWC, we add more than 90 numeric psychologically meaningful features to our dataset. Applying logistic regression, we build a joint model for both text and LIWC features. In next step, we evaluate and tune our model using cross-validation and grid search. Finally, we use our model for predicting users' educational background using test set. Table below compares the classification evaluation reports for 4 different approaches that have been tested in this study. As can be seen, BLIWC model, which is using a combination of words and LIWC features, is providing more accurate predictions rather than other models. With adding LIWC features to the bag-of-words, we see an improvement of 2% in the accuracy of final predictions. Besides, in addition to a list of words for each class, we have some features which are more interpretable. To have a comparison between true labels and predicted labels, 4 possible situations are summarized in following confusion matrix. Tn shows the number of labels that the classifier predicted correctly as low education. Fn shows the number of instances with true label high education that are predicted with low education label incorrectly. Fv shows the number of instances with true label low education that are predicted incorrectly as high education class. TP is the number of instances that the classifier has labeled correctly as high education class. In this matrix, the successful predictions are along the main diagonal. As can be seen, out of 9,361 total predicted labels, 7,773 labels are predicted correctly. Looking separately, out of 7,516 predictions with high education label, 6,615 ones are predicted correctly, and out of 1,855 low education predicted labels, 1,158 labels are predicted correctly. This figure shows the future importance of LIWC features that are derived from BLIWC model. Features with positive coefficients are the ones that are more prominent in the instances that are labeled with high education label, and negative ones are the ones that are more prominent in instances that are labeled with low education. As can be seen in this diagram, users with class label high education follow more writing rules, such as using parentheses, punctuations, apostrophes, colons, or dashes. Users in this class mainly focus talking about the past sign, and while writing, choose more longer words, longer than 6 letters. While in the other class, users use more informal language, focus on future tense, and use more negative words in their written text.
First of all, overall, we found that we can identify highly educated authors with reasonable precision. So given a body of text, we can, to some extent, say whether the author was most likely highly or low educated, which is useful in itself. Furthermore, we find that somewhat surprisingly, the back-of-word approach outperforms other approaches like looking at higher level linguistic features or psychometric features of the text, which is somewhat surprising as intuitively you would expect that higher level features of the text would be more informative than just the particular words that people use in no particular order. Also, from a substantive or theoretical perspective, this is somewhat unsatisfying as the back of words result makes it harder to come up with hypotheses about specific features of a text that would be predictive of an author's social background. So in future work, we'll be looking at ways to improve this result and make it a little bit more useful. So the first thing we want to do is look at further linguistic features, in particular elements of grammar and style, but we are still looking for ways to quantify such features. Second, even though the data set that we had is useful in the sense that it provides both user-written text and detailed background information, it is not an ideal data set in particular because the level of education has so little variance, forcing us to recode it into only two categories. So ideally, we would also try this at a different data set, which has a little bit more fine-grained levels of education measured. Also, and a little bit longer run, would be nice to try to apply this also to different languages and see if the results are similar. So overall, we hope this is a useful first step in studying to what extent social backgrounds is reflected in user-written text, which is hopefully useful for answering the type of questions that I had about inequality in the platform economy, but may also be useful from a more methodological perspective, for example, in scenarios where you have user-written text on a particular population, but no measures of social background, and where you could use such measures to use written text as a proxy for measuring social background. So I hope you found this useful, and we'll be happy to take any questions.